Today we are working with what I like to call eureka numbers. We are looking for the missing term in arithmetic progressions. We are making a deadfish swim for whatever reason. We are working with reverse Polish notation, and then we are playing around with integer range extraction. Hello world, and this is versus Codewars. We begin today with the warm-up segment, a series of easier katas in order to prepare for the more difficult katas later in the episode. Starting with a trip to the zoo. You take your son to the forest to see the monkeys. You know that there are a certain number there, n, but your son is too young to just appreciate the full number and has to start counting them from 1. As a good parent, you will sit and count with him. Given this number n, the goal of this kata is to populate an array with all numbers up to and including that number, but excluding 0. Let's go ahead and get started with this one here. We're going to do const monkey count. We're going to pass in our number as our lone argument here. And what we're going to go ahead and do, we're going to go ahead and keep track of an array here of our result. And that's going to be what's returned. And what we'll go ahead and do is we're going to do a for loop here. For let index equals 1, index is less than equal to 10, or rather number plus index. And what this will go ahead and do, we'll start our index out at 1. We're going to keep looping until our index here, as long as our index here is less than or equal to the number that we pass in here. And then for each iteration, we iterate our index by 1. Alright, what we'll go ahead and do with this index here is we're going to go ahead and push that into our results array. And we'll do that by doing this. Result.push. And we're going to pass in our index right here. Alright, let's go ahead and punch this into Codewars and see what that looks like here. And we are good on that. Our next warm-up kata, we are back in an earlier warm-up kata in an earlier episode of Versus Codewars, we did a warm-up kata where we converted a number into a string. Now we are converting a string into a number. We need a function that can transform a string into a number. Let's go ahead and give this a try here. I'm going to train const string to number. It's going to take our string as an argument here. Alright, what we can go ahead and try doing here, JavaScript has a couple of useful utilities to be able to accomplish this. One of them is, and I think you may have seen this in previous episodes, the parse int function. This function attempts to parse a string into an integer and returns the integer if successful. And we can call that by doing this. Return parse int, and we'll pass in our string right here. I'm going to go ahead and punch this into Codewars and see what that looks like. And we are good. But before we move on, there's some other ways I think we can go ahead and do this as well. The number object in JavaScript has a constructor that can have a string passed into it. And this constructor should be able to convert that string into a number. And we can call that constructor by doing this. Number, and we pass in string to that constructor right here. Let's try that again here, and we are good on that. I think there is yet another way to do this as well. Recall that one of the ways that we used to convert a number into a string back in our earlier warm-up kata was to take that number and concatenate an empty string to it. I just wonder if the same principle works in reverse. Let's give it a try. I think it's return string plus 0. Yeah, let's test that out here locally. Console.log string to number and pass in 20 here, for instance. Let's run this in a node and see what that looks like here. Warm up string to number. And you know what? I do believe that returns a string as well. Alright, oh well, never mind that. On to our next warm-up kata here. Alright, we are breaking chocolate. Your task is to split a chocolate bar of a given dimension, n by m, into small squares. Each square is of size 1 by 1 and is not breakable. The goal of this kata is to implement a function that will return the minimum number of breaks needed to split that chocolate bar into its individual 1 by 1 squares. Let's go ahead and give this a try here. Alright, we're going to do counts to break chocolate. We're going to have our n and our m as our two parameters here. Alright. For instance, if you're given a chocolate bar of size 2 by 1, you can split it into single squares into just one break. But for size 3 by 1, we have to do 2 breaks. Now, I think what we can go ahead and try doing is... Okay. We're going to go ahead and keep track of our break count here. And that's going to be what's returned here. And what we'll go ahead and do is, while n is greater than 1 and m is greater than 1, we'll do a while loop here, and we'll continue as long as our row and our column lengths are greater than 1. Or rather, should this be an OR here? I think so. Alright. I think we'll try going ahead and if n is greater than or equal to m, and we'll have an else case here. So I'm picturing if one side of our chocolate bar is longer than the other, then I think we'll go ahead and take the shorter side. No. Okay, take the shorter side, break that off. So m minus equals 1. And then do break count plus plus, and then we'll take the part of the chocolate bar that was broken off, and we need to break those into 1 by 1 squares. And I think we can do that by doing this. First we'll do break count plus equals 1, actually. And then plus n minus 1. And then, otherwise, if our m is greater than our n, we'll go ahead and do n minus equals 1, and then break count plus equals 1 plus m minus 1. I think that's how we're going to go ahead and be able to do this. Let's go ahead and test this out here. Console.log break chocolate. Let's pass in 3 and 1 here. I should expect to see 2 returned here. Let's go ahead and test this out. Warm up, run this through Node and see what this looks like here. Whoops. Node warm up break chocolate. And we have an infinite loop here, I'm sorry to say here. Let's go ahead and debug what's going on here. Maybe it's and. And, yeah, that is not what we were looking for. Maybe while n is not equal to 1, or m is not equal to 1. Okay, we have an infinite loop here, I'm sorry to say. Alright, let's go ahead and console.log in our while loop here, our n and our m. Ooh, that's not what we want either. Well, n is greater than 1 or m is greater than 1. How about this? Or maybe both. Instead we get back 0. Okay. Alright, I have a new idea. While n times m is greater than 1. Alright. 3 and 1. Greater than or equal. Yeah, well, n times m is... Now, wait a minute. What if I tried this? Instead of a while loop, how about we do a do while loop here? Do while n times m is greater than 1. I'm afraid that's not it either. Or maybe if we reversed these here. Yep, and we get 2 here. How about if we pass in 2 and 1 here? Alright, let's go down to our tests here and see what those look like. Here is a 5x5 chocolate bar. And that returns 24. And that is what we want here. What about 1 and 1? That returns 1, and we do not want that. Alright, we'll do a little bit of a sanity check up here. If n times m is equal to 1, then we return 0. Alright, let's go ahead and get rid of our console.log here. Let's punch this into Codewars and see what this looks like here. Let's run the tests. And we are good on that. Our next warm-up kata. We are given a number, and the goal of this kata is to write a function that takes that number and returns the number of special steps needed to obtain a palindrome. The special step is as follows. Reverse the digits and then add that resulting number to the original number. If the resulting number is not a palindrome, repeat the procedure with the sum until the resulting number is a palindrome. If the input number is already a palindrome, the number of steps is 0. Let's go ahead and give this one a try here. Const palindrome chain length. And we have our number as a parameter right here. Alright, we're going to go ahead and keep track of our steps here. And we're going to return true if we're going to return the steps here, rather. Alright, we have to return the number of steps here. Alright, what we'll go ahead and do is we're going to take that number. We need to take that number, convert it into a string, split it into its individual characters, reverse those characters, join that resulting string back together, and then convert it back into an integer. We'll do this. Let reversed number equal parse int number.toString split with a blank string separator reverse.join. I'm going to go ahead and split that off into a couple lines here. Maybe not. Okay. All right, well, we'll go ahead and do from here. While number is not equal to reversed number. I'm going to do steps plus at the end of this while loop here. And what we'll go ahead and do is we're going to take number and we're going to add that reverse number to it. And then we're going to go ahead and repeat that process with our reversed number right here. Alright, this should do here. Let's go ahead and test this out here. Console.log palindrome chain length, and we're going to pass in the number 87. I expect this to return 4. Let's do node warmup numeric palindrome. And we have an infinite loop here. What is going on? Alright, we have the number here. We add the reverse number to it. We take the reverse number and we reverse that newly added number here. Let's go ahead and console.log these here. And we're going to go ahead and run this again here. And that does not seem right. Alright, what is going on here? Because we are not joining these together with blank string separators. Whoops. Alright, let's try that again here. And yep, it's now working here. Alright, let's go ahead and test this out with some of our other functions here, our tests here. 0 here. How about 89? Expect to see 24 here. Yep. Alright, let's go ahead and get rid of this console.log here, and let's go ahead and punch this into Codewars and see what this looks like. And run the tests. And we are good on that. Our final warm-up kata here, we are doing a little bit of a callback to our very first kata on Versus Codewars. We are given a number, and our goal here is to return the maximum number that can be formed from the digits of the given number. Let's go ahead and give this one a try here. Alright, const max number. We're going to pass in a number here. Alright, we're going to do the same thing we did in our previous warm-up kata here. We're going to go ahead and do this. Const chars equals number dot toString, and we're going to split that into its individual characters here. And what we will go ahead and do is we're going to go ahead and we're going to go ahead and change chars here to digits, and we're going to go ahead and convert each of these to numbers. We're going to do that with a map method, pass in our char to our predicate function, and we're going to return parse int char, just like that. And what we'll go ahead and do from here, we can run this through the sort method to sort these in descending order. And we can do that like this. Not sort a b for our sorting function, b minus a, to sort these digits into descending order. And what we should be able to do from here, return parse int. We're going to do digits dot join with a blank string separator. All right, let's go ahead and test this out here. Console.log max number 213. Let's feed this in a node and see what that looks like. And we get 321. Let's go ahead and pass this in the Codewars and see what this looks like. Yeah, run the tests. And we are good. And that concludes today's warm-up segment. I will see you in the next kata. Consider the number 89. Split that number into its individual digits and then raise them to consecutive powers starting at 1. For instance, you raise 8 to the power of 1 and 9 to the power of 2. Add those numbers together and you'll find that that sum is equal to the number 89. Consider next the number 135. You split those into its individual digits and raise those digits to consecutive powers starting at 1. You raise 1 to the power of 1, 3 to the power of 2, and 5 to the power of 3. Add those resulting numbers together and you'll find that the sum is equal to the number 135. For this kata, we will be looking for numbers within a given range that fit the following property. The sum of the number's digits raised to the powers of those digits' indices starting at 1 is equal to the number given. Alright, let's go ahead and give this one a try here. Our goal here is to return an array of all those eureka numbers. Alright, let's go ahead and give this one a try here. First, I think we'll need a helper function here. Const is eureka. It's going to take a number here. And what this helper function will do is we're going to go ahead and const reversed. No. Sum of powers. And what we'll do is we're going to take that number, convert it into a string, split it into its individual characters, convert those characters into integers, and then we're going to run that through the reduce method here. Const reduce. We're going to have our accumulator, our digit, and our index here. And we're going to do ec plus math.pow digit index. And we're going to have our base accumulator, our initial accumulator at 0. And we're going to return true if number is equal to sum of powers. Alright, so what this helper function is doing here, it takes a number as a parameter here. It takes that number, converts it into a string, splits it into its individual characters. It then runs the resulting array through the map method, converting each character into an integer to get its digit. And then takes that resulting array and runs it through the reduce method, which has a predicate function which takes an accumulator initially set to 0, the digit being worked on, and the index of that digit. We take the accumulator and we add to it the return of the math.pow function, taking the digit as its first argument and the index plus 1 for the exponent here. So we're raising digit to the power of index plus 1. We add that to the accumulator right here as we said before. Now we take that resulting number and we check to see if it's equal to the number that we pass in. If it does, we return true because that is what we call a eureka number. Alright, let's go ahead and put this helper function to use here. Now, this range here is going to be inclusive. So we're going to start our for loop at the lower bound and then we're going to go up to the upper bound here. So we're going to keep track of a result array here. And that is going to be what's returned. All right. And by the way, if our number is less than 10, we return true anyway, because our number here has only one digit. Anyway, we go to our for loop here. For let index equals the lower bound. Index is less than or equal to the upper bound. Then plus index. All right, what we'll go ahead and do is, if is Eureka, and we pass in our index here. And if that returns true, we go ahead and push that index into our result array here. All right, that should do it here. Let's go ahead and test this out here. Console.log some dig pow. Pass in 1 and 100 here. Let's go ahead and test this out here. Node eureka power.js. And we have the array 1, 2, 3, 4, 5, 6, 7, 8, 9, and 89. All right, let's go ahead and have a look at some of our tests here. Let's try 90 and 100. That should give us an empty array. How about 10 and 150? 89, 135. We want to see that. All right, let's go ahead and punch this into Codewars and see what this looks like here. And we'll run the test here. And we are good. Not really much to say about this one, but instead of the math.pub function, what you could also use is JavaScript's exponent arithmetic operator, which is denoted by 2 asterisks. Take the left-hand value, place the 2 asterisks, and then the right-hand value. And what this operator will do is take the left-hand value and raise it to the power of the right-hand value. You'll get the same result if you do that. An arithmetic progression is a sequence of numbers such that there is a constant difference between the terms of that sequence. Given an array of numbers making up one such progression, only with one number missing, the goal of this kata is to seek out and return the missing term in that arithmetic progression. The given array will always contain at least 3 numbers, and the missing term will never be the first or the last one. Let's go ahead and give this a try here. Alright, what we're going to go ahead and do first, we're going to go ahead and copy this. We're going to do a console.log, and we're going to log the return of this out to the console here. Alright, what we'll go ahead and do here. Now, in an arithmetic progression, the difference between one term at a given index and the term before it in the progression will always be the same. So what we'll go ahead and do, we'll go ahead and keep track of all the differences between the terms of our progression here. And we'll do that by doing this. Constant differences. We're going to go ahead and set this to an empty array. We are going to loop through the terms of our progression starting at index 1 instead of index 0. And we're going to loop to the end of our progression here. And we're going to step by 1. And what we'll go ahead and do from here is we're going to do differences, not push, and we're going to push into this array the difference between the term of our progression at the current index and the term of our progression at the index before it. All right, what we should be able to do now, I think if I'm not mistaken, if there were to be an index in this, a term in this progression missing, we should be able to pick that up by looking for the largest difference in between the terms of this progression here. So what we are going to need to do is we need to figure out what the minimum difference and the maximum difference is in between each of the terms of our progression. And we'll do that by doing this. Const minimum min difference. And we'll do math.min, and we'll spread out our differences here as arguments in the min function here. This should give us our minimum difference, and if I'm not mistaken, that should be the intended fixed difference between the terms of a progression here. Not necessarily. Yeah, we are going to need that actually. Next, we'll go ahead and determine what the maximum difference is, because if there's only one term of this progression missing here, there should only be one difference in our differences array that's different from the others, and we should be able to pick it up by doing what we're doing here. We'll do const max difference, and we'll do math.max. And we'll spread again our differences array here into arguments for this function call here. Now, we want to figure out the index of this max difference here. And we'll do this by doing this. Const max diff index. And we'll do differences.index of max difference. Now, if I'm not mistaken, differences at index 0 should be the difference between index 1 and index 0 in our progression here. So I think what we can do is, so this would be differences 0, this would be differences 1, this would be differences 2, and this should be differences 3. So I think what we can go ahead and do is we'll return progression at index max diff index plus the min difference. Alright, let's explain what's going on here. We have our Kata solution, find missing, and we have one argument here, which is an array of numbers representing the arithmetic progression, only with one number missing here. Alright, we keep track of the differences between the current term and the term before it in this differences array here, and this for loop populates that array here with such differences. Now, we calculate the minimum difference here of which this array should contain the majority of. And we do that by doing math.min, and we spread out the terms of our differences array into arguments here. We do the same thing with the max difference as well, because if I'm correct, then the max difference should be located at the point of our progression where we have our missing term. We get the index of this max difference right here. And then we take the progression at the index of our max diff index and we add the min difference here. And that should give us our missing term. Let's go ahead and test this out here. Node arithmetic progression. And that does give us 7 here. Let's have a look at some of our tests here. Here we have a term with 3 numbers, 1, 3, and 4. I expect to see 2 return here. And we do in fact see 2 returned here. Let's flip it up here, 1, 2, and 4. And that gives us 3, and we love to see that. Let's go ahead and try punching this into Codewars and see what this looks like. And, okay, we've got a problem here. What is the problem? Expecting minus 240, instead got... Uh-oh. Okay, let's go ahead and console.log our progression here. It would seem our code breaks when we're dealing with descending order. I have an idea. What if we put this in math.abs, make this an absolute value here. Alright, let's go ahead and take this sequence of numbers here and run that through our local solution here. Alright, speed that into node. -4, -2. It should be -1, or rather 1. Alright, let's go ahead and console.log our progression and our differences. Alright, what we'll go ahead and do. We'll do a flag here. Alright, we're gonna go ahead and if progression at index is less than progression at index -1, we'll go ahead and set our descending flag to true. And then in our return here, we'll do descending min difference. Alright, let's try this here, and we do get 1 here now. Alright, what was happening was I was failing to account for instances for progressions in which numbers were in descending order. So what I do here, I have a flag here that I will set to true if the term at the current index is less than the term before it. That way I know this progression is in descending order. I take the difference between the term at the current index and the term of the previous index and run that through the ABS function to return the absolute value of that difference. I do the same thing as I did before here, but now instead of what I did before in the return here, I check to see if descending is set to true. If it is, I subtract the min difference from the term at the index of max diff index. However, if descending is false, I instead add the min difference here. I seem to have got it right now. Let's go ahead and feed this into Codewars and see what this looks like. Let's run the tests. And the test passed. Let's hit attempt. And we are good. Here's where I slipped up with this Kata solution. I was failing to account for instances, progressions in which the numbers were in descending order. What I had to do to alleviate this was I had to set a flag to determine if this progression was in descending order rather than ascending order. And then, when I was calculating the differences between the terms in the progression, I had to use the absolute value of that difference in order to avoid dealing with negative numbers. Now, at the end of the function, what I had to do was take the progression at the index of the maximum difference in our differences array, and then either add or subtract the minimum difference depending on whether the progression was in ascending order or descending order. If the progression was in ascending order, I would add the minimum difference. But if the progression was in descending order, I would subtract the difference to get the missing term in our arithmetic progression. This is a Deadfish parser. This parser accepts 4 commands represented by characters in a given string, which manipulate a number. The commands are as follows. I increments the value, which starts at 0. D decrements the value, subtracting 1 from it. S squares the value, taking the value and multiplying the value itself. And then O pushes the current state of that value into an array, which will be returned at the end of this kata solution. Given a string with the above command characters, the goal of this kata runs the commands and returns the resulting array. Let's go ahead and give this a try here. Alright, we're going to go ahead and keep track of a result array here. Or I have a better idea. How about we do this all in one line here? Alright, we'll take our command string. I think we need to account potentially for lowercase letters, right? That's something I'll consider if I need to. Anyway, we'll take our command string, split it into its individual characters, and then we'll run each character by the reduce method. Alright, this method will have an accumulator, which is initially set to an empty array. We'll have our command right here. And what we'll do here is, in our function body, we're going to go ahead and run this by the switch statement. I have another idea. How about we use an object here? Value 0 and then output. And then we'll return the output here. What we'll go ahead and do is, I think what we do is switch command. And then we'll do case. Okay, what we'll do. Alright, we're going to go ahead and pull that value and output out of our accumulator here. And then what we'll do is switch command case I will increment our value here. Case and D will decrement our value here. Case S will do value times equals 2. This is the aforementioned exponent arithmetic operator, in which we take the left-hand value and raise it to the power of the right-hand value here. This is the variation of it where we do kind of like what we do with value plus equals 2, which would be the same as value plus 2. Value equals value plus 2. We do value times equals 2, which would be the same as value equals value times 2. And then finally we have our command O, which pushes the current state of our value into the output array. And then at the end of this, at the end of our predicate function here, we will return an object with our new value and our new output. Alright, and at the end of this, we return the output here. Let's go ahead and test this out here. Console.log parse, but the one in this example here, IIISDOSO. Alright, let's feed this in a node and see what this looks like here. Assignment to constant variable. This needs to be let. And we have an array 8 and 64 here. Alright, how about this convoluted string here with some invalid commands? We still get our 8 and 64 here. Alright, let's go ahead and feed this into Codewars and see what this looks like here. Run the tests. And we are good. Now here is an instance where I was being a little too overly clever when I didn't need to be. What I could have simply done was use a results array like what we have been doing with all of our other Kata solutions, and then returning that results array at the end of our Kata solution. And then using the reduce method, as we did do in our Kata solution, and if statements instead of our switch statement. I could have pushed the current state of the value into a results array when we ran across the O command in our Deadfish string. It's always a good idea to make your code readable, even if it means sacrificing a little bit of cleverness to do so. This is a reverse Polish notation calculator. Given a space-separated string containing numbers and arithmetic symbols, the goal of this kata is to calculate the reverse Polish notation expression and return the result. Alright, let's go ahead and actually first do a console.log, and I'll give you a string to let you know what I'm talking about here. I'll give you this string from the kata instructions here. 5, 1, 2, plus sign, 4, times sign, plus sign, 3, minus sign. Alright, what this kata solution should be able to do is to calculate the solution of this. This is the reverse Polish notation expression here. This expression is equivalent to the normal notation equation 5 plus 1 plus 2 times 4 minus 3. And this equation here should equal 14. Alright, let's go ahead and give this a try here. I have a feeling we're going to be working with stacks here. Now, what we'll do is, first we need to separate this string into its individual tokens using a space separator here. And we'll do that by doing this. Const tokens equals expression.split, and we'll use a space separator here. Now, we need to check on a couple of edge cases here. If tokens.length is 0, we'll go ahead and return 0. Now, if tokens.length is equal to 1, we're going to go ahead and try returning the lone token in this expression into a number. And we can do that by doing this. Const converted equals number tokens at 0. I think numbers constructor returns not a number if this constructor cannot convert this token into a number. Let's console.log that and see if I'm right. I'm going to go ahead and comment this out here. And we're going to do calc, just a plus sign here. Let's feed this in a node and see what that looks like. And it does in fact return not a number. So with that being said, what we can do here is if number.isNan or isNan converted is equal to true, or rather we can do return number.isNan converted. If it's true, we return 0, otherwise we return converted. Alright, what we can go ahead and do from here, now that we have all the edge cases out of the way here. Alright, I think we're gonna be dealing with stacks here. So we're going to go ahead and keep track of a stack array here. And what we'll go ahead and do, we're going to go ahead and iterate over each of our tokens here, rather const token of tokens. And what we'll do is we're going to go ahead and check to see first if each of our current token is one of the arithmetic operators here. Or rather, switch token case plus sign what we'll go ahead and do, I think we go ahead and pop those two numbers from our stack here. Alright, here's what we'll do. We need to keep track of a result here, too. Alright, we'll do result. Wait a minute. No. Okay. Okay, what we'll go ahead and do. Stack at, I don't know if add support in this version of Node here. I want to see something very quickly here. NVM use 10. NVM install 10. NVM use 10. Node. Let's see here. 1, 2, 3 at -1. And is not a function. Okay. So yeah, that's not going to work here. So what we'll need to do, stack at stack dot length -2 equals stack at stack dot length -2 plus stack at stack dot length -1. And then we'll go ahead and pop that value out of our stack, off the top of our stack. Or rather, we can make this a little easier by doing this, stack.pop, which returns that value here. All right, break here. And we're going to go ahead and repeat that for the other arithmetic operators here. Minus, times, and divided by, Now, the Kata instructions say we can assume that there won't be any exceptional situations like a divide by 0, so we probably will not need to check for that. Now, in our default case here, we need to push our number into, in the default case here, this token is going to be a number here. So we'll go ahead and attempt to parse this as a number, and we'll go ahead and place that number in our stack. Stack.push. I think we'll try using numbers constructor to do this here. Alright, I think that is I think that is how we are going to do this here. Alright, I'm going to go ahead and uncomment this line here. So what I think this should be able to do is we push 5 onto the stack, push 1 on the stack, 2 on the stack. And then we encounter this plus sign here. We take the 1 and the 2 here, pop the 2 out of the stack, and then add it to this 1 right here. Now 3 should be on top of the stack. Next we push 4 onto the stack, and then we run into this multiply sign. We take the 3 and multiply 4, we should get 12. Okay, let me reiterate this here. Alright, we start with the 5 on top of the stack. Then we push the 1 onto the top of the stack. Then we push the 2 onto the top of the stack. And then we pop 2 out of the stack, and then we add it to the 1. So our stack should now be 5, 3. We run to the 4 here. Our stack should now be 5, 3, 4. We run to the multiply sign here. We pop 4 onto the stack, and we multiply that by 3. Our stack should now be 5, 12. And we run to this plus sign here. We pop 12 onto the stack, and we add 5 to it. We should now have 17. We push 3 onto the stack. Our stack should be 17 and 3. And then we pop 3 onto the stack, and we subtract 17 by 3. And that's how we should arrive at the number 14, which should be the low number on the stack. And that should be our solution here. So what we should be able to do now is at the end of this, we return what should be the lone element in our stack, which will be our solution here. Let's go ahead and test this out here. Node reverse Polish, and we do get the number 14. Now, I could probably expect... Now, let's try 3.5 here. We should be able to get 3.5 here. Yup. 2 times. That gives us 7. Let's do a plus instead here. It should give us 5.5. That's what we want. Okay, I feel comfortable with this. Let's punch this into Codewars and see what this looks like here. And we are good. Now, I have never heard of reverse Polish notation until today, so I'm always glad to learn something new every day. Moreover, in this Kata solution, we were working with stacks, pushing tokens onto stacks and popping tokens from stacks. In this particular case, we were iterating over each of the tokens in our reverse Polish notation expression here. We were pushing numbers onto stacks here, and whenever we encountered an arithmetic token, plus, minus, times, or equals, we were popping numbers onto stacks, and then performing that particular arithmetic operation, adding, subtracting, multiplying, dividing upon the number that was the last one on the stack after we popped that number out. This is an example of us working with the stack data structure and stack algorithms. Given an array of integers, the goal of this kata is to return a string with a comma-separated list of individual integers and ranges of consecutive integers such that the start and the end of those ranges are separated by a dash. Now, for the sake of clarity, let's read the Kata instructions here. A format for expressing an ordered list of integers is to use a comma-separated list of either individual integers or a range of integers denoted by the starting integer separated from the end integer in the range by a dash. The range includes all integers in the interval, including both endpoints. It is not considered a range unless it spans at least 3 consecutive numbers. For example, 12, 13, 15-17. Complete the solution so that it takes a list of integers in increasing order and returns a correctly formatted string in the range format. Like in this below example here, which I will copy into the local solution here. Console.log. I'm going to paste this here. Alright. Let's go ahead and give this a shot. Alright, first we need to go ahead and make sure this is sorted in ascending order. So we'll do integers dot equals integers dot sort a minus b, so that we are sorting this in ascending order. All right, what we'll go ahead and do, I think we'll go ahead and we'll keep track of a result string, and that's going to be what's returned. We're going to keep track of, I think, the current token. All right, let's go ahead and iterate through each of our integers here. For const int of integers. Actually, what we actually need to do is for let index equals 0, index is less than integers dot length plus index. And what we'll go ahead and try doing here is, now if the token is blank, we'll go ahead and just append this token, append this current integer into our token and continue. Integers, add index, continue. All right. Now we can safely assume that this token string will be empty if we're at the first index of our integers array. So what we'll go ahead and do is, I think if maybe keep count of the number of consecutive integers here. Let consecutive count equals 0. Or rather 1. Now, if the current integer, the integer at the current index, minus 1 equals the integer at the index minus 1, what I think we'll go ahead and do, we'll increment our consecutive count. And need to keep track of a lower bound here. Let lower consecutive lower bound, set that equal to 0 for now. Okay, yeah, we'll go ahead and set that to number min safe integer here for now. And otherwise, if this is not a consecutive integer, we'll go ahead and set our consecutive count to 1, and we'll reset our consecutive lower bound here. And we actually go ahead and set that to our integers at index here. And now if we'll go ahead and keep track of a consecutive upper bound here too. Or maybe not. All right, if we end up here, if our consecutive count is greater than or equal to 3, we'll go ahead and modify our token here with our consecutive lower bound, 2 integers at index minus 1. And I think we'll go ahead and put the comma before that. And I think we'll go ahead and try appending that to our result string. Okay, all right, let's first explain what's going on thus far here. All right, we have our integers sorted in ascending order here. We have our result string, which is going to be returned. We have our token string, which represents the current token of our comma-separated list of integers here. All right, we're keeping track of a consecutive count, which keeps track of how many consecutive integers that we have run into in our sequence of integers here. And we are keeping track of a consecutive lower bound, which is going to be the lower bound of that consecutive run of integers here. Now in this for loop here, if our token is empty here, we can safely assume our token is going to be empty if we're starting out at index 0. So we go ahead and append that integer to our token here. Now here. Okay, well, we'll go ahead and try doing here. All right, first check to see if the token is, or rather if the result string is empty. Okay, maybe if we all right, we're gonna go ahead and this integer here. if our index is 0, let's go ahead and set the token to the current integer and the current index. And then we'll just go ahead and hit continue here. Now, if the next integer after that, now we're in the next part of our iteration here. If integers at index -1 plus 1 is equal to integers at index, we'll go ahead and increment to the consecutive count. And then we'll go ahead and set the lower bound of that. We'll go ahead and set the lower bound of that. Okay. First, we'll check to see if the consecutive count is 1. Then we'll go ahead and set the consecutive lower bound to integers at index -1. Then we'll increment the consecutive count. And otherwise here, what we'll go ahead and do is we'll set our consecutive count back to 1 here. Now, if our consecutive count as a result is greater than or equal to 3, and we'll have an else block here. So if our consecutive count would be 2, we would go to this else block here, in which case we would append our token with a comma and then our current integer. Now, if our consecutive count here would be 3, what we'll do instead, we'll replace this token with a range here, starting with our consecutive lower bound, and we go to integers at index right here. I think we'll go ahead and actually track this as an array here. All right, what we'll go ahead and do here is at index -1 and then comma that right here. Alright, otherwise our consecutive count would be at 1. push. I think we'll do the same thing we did in here as well. And I think we'll go ahead and push that into a result here. And then we reset our token. No. Okay, well, actually we need to go ahead and do. Alright, we start with this token right here. Okay, we set our consecutive count. Push what we had in our token here. Reset the token to integers at index right here. I think that's how we're gonna do this here. Now, once we reach the end of our for loop here, if index plus 1 is equal to integers.length, then we will go ahead and push what we have in our current token here, like this. And then we'll have this array right here. I'm gonna leave that array untouched right now. Let's go ahead and test this out here. Node range extraction. Consecutive count is not defined because somewhere I misspelled consecutive. I misspelled it right here, and I think I may have misspelled it right here as well. Let's try that again here. And we have an array, -6, -3 to -1, 3 to 5, 7 to 11, 14, 15, 17 to 20. That is what we want here. All we need to do is just join these together with a comma separator. And I believe that is the string jhoffner here is looking for. Alright, let's go ahead and unfortunately, that seems to be the only test right here. So let's go ahead and punch this into Codewars and see what this looks like. Do we run into any problems here? No, we do not, and we are good. Here is the better code solution of the day. Pay mind to the rather large code snippet you see obstructing my face here. This code snippet is quite more readable, quite more so than our own Kata solution here. As you can see, this solution is split into 3 separate functions. Our solution function, a function called split into ranges, and a function called convert to range. First, we take our individual integers and we run it through the reduce method. With an initial accumulator set to an empty array, we call the function split into ranges on each integer here. Now, the split into ranges function takes 2 arguments. Our accumulator, which is our array of ranges arrays, and the current integer. We first check to see if the ranges array is empty. If it is, we push an array into that ranges array with our number, and we return the ranges array, which will be used for the next iteration of the reduce method loop. Now, we have 2 variables here, one called last range and one called last number. Last range is set to the last array of integers in the ranges array, And then we have last number, which is set to the last number in that last range. Now, depending upon whether the last number plus 1 is equal to the number that we have passed in, we either push the number into that last range array, or we push that range array into our ranges array, and then we return the ranges array for the next iteration of the reduce method's predicate function. Now, we take that resulting array and we run that through the map method. And for the predicate function of the map method, we use the function convertToRange, which takes the range array as an argument here. Now, in this one, we check to see if the length of that range is less than 3. If we do, we join the numbers in that range together with a comma. If it is greater than or equal to 3, then we take the first integer of the range and the last integer of that range, and we separate them with a dash, and we return that instead. Now, we take that resulting array from the map method and we join it together with a comma separator. And after all of that, we should have the same return value as we did in our Kata solution. And that is going to do it for today's episode of Versus Codewars. If you like this video or you learned something new, drop a like and subscribe to this channel to see me take on more coding challenges on Codewars. As always, if you think there's anything I can do to improve on my code for the better, feel free to drop a suggestion in the comments section below. Also, if you are a Kata author on Codewars and would like to share your authored katas with me, feel free to drop a link to those katas in the comments section below as well. And you might see me solve those katas on a future episode of Versus Codewars. I hope you have a wonderful day, and I will see you on the next episode of Versus Codewars.